The places where stars and planets are born are among the galaxy's most beautiful locales. These cosmic landscapes change as new generations of stars light up and disperse their birth cloud. But the youngest stars seen here are already perhaps 1,000,000 years old. Hardly toddlers.
Stars and planets form in the dark, inside vast cold clouds of gas and dust, such as these pillars imaged by the Hubble Space Telescope.
The dust is so thick we can't see the infant stars inside, at least not with visible light.
With infrared light, Hubble can see through all but the thickest dust. Yet it's in those dense knots that the youngest stars are forming.
To peer inside them, astronomers need the James Webb Space Telescope.
With a mirror larger than Hubble's and performance optimized for the infrared, Webb will give astronomers their closest look yet at stellar birth.
We're flying through a computer model that represents astronomers' best ideas about the star formation process.
Reddish colors indicate thicker dust. The temperature, less than 400 degrees below 0 Fahrenheit.
Or less than 240 degrees below 0 Celsius.
That pinwheel ahead is a protostar, perhaps 10,000 years old. Protostars arise when a dense light-year across collapses. But the details of the process are not well known.
Elsewhere in the cloud, another protostar is preparing to build planets. As the cloud that created the protostar collapsed, it flattened into a disk. The disk we see here is 600 times the size of Earth's orbit around the Sun.
If placed in our solar system, it would extend far beyond the planets.
In this computer model, the disk continues to accumulate gas and dust from its surroundings for thousands of years. Eventually, the disk fragments, producing dense, bright structures. These may become sites where giant planets form.
Later, during another phase of construction, smaller Earth-sized planets may take shape.
At least, that's what scientists think happens. It will take the Webb telescope's keen infrared eye to see what's really going on in the cold heart of stellar nurseries.
Stars twinkle because of tiny variations in temperature and density in the layers of the atmosphere, which very slightly bend light coming from stars. You can see the same effect behind jet engines and above fires, like this photo taken through the hot air above a ship's chimney. The temperature variations naturally in the atmosphere are much smaller, so the effect is not directly visible, except for causing stars to twinkle. This is a simulation of Saturn as seen through the atmosphere. It's not an accurate simulation, but it's good enough to demonstrate the basic idea. As the pockets of warm and cool air churn in the atmosphere, different parts of Saturn get magnified and shrunk at different times. With the naked eye, you can only perceive the overall brightness, so the overall effect is averaged out and you just see a steady point of light. Even though a star is actually much larger, it's much further away, so appears as a tiny point, even compared to a distant planet. This single point gets alternately magnified and brightened, or reduced and dimmed, as the precise path that its light takes through the atmosphere changes over time. Even though the side-to-side movements of the star are too small to be perceived, the changes in brightness are visible. So that's why stars twinkle and planets don't.